Okay. So once again, when they say here's a differential equation, all they're really saying is we're giving you this formula, and there would be some formula here, but we're not giving it to you. That's all they're doing. Question? Okay, cool. It says find the particular solution. That again is just a kind of mathematical way of saying please find this equation. Find this equation. Question? If you have a really simple derivative like this, you can kind of just look at it and say, oh, well, the original equation was this. Because it's simple enough to see the relationship. Questions? So like over here, you know, if we were Danica's charting this, we'd say we got y. Our equation for y is x cubed. Our derivative is 3x squared. Okay? So I'm just trying to get you to understand the big idea. It is critical that you understand when you see the words, you know, here's a differential equation, you don't freak out, you say, no big deal, they're just giving me this. Okay? But the problem is our equation isn't simple enough to just kind of identify what goes here. So we have a method. I have an acronym to help with this method.
Mr. Smith,
Yes.
Allie Campbell is being checked out.
Okay.
Thank you.
I say the sassy method. It sounds edgy to me, so it's the sassy method. I feel like I'm saying the wrong words. Edgy the right word? As edgy as I get. So, sassy method. Like, was this the class where I said saucery?
No. Everyone knows that.
Everyone knows that.
Everyone watched that video.
Everybody saw saucery instead of, how do you say it?
Sorcery.
Saucery is like what they do at Olive Garden. That's saucery. So Marin got to meet Alan H. Oakes. She told me that Alan H. Oakes is like me, laughs at his own jokes. And I said, so he's not funny either, right? Moving on. Okay.
It could be compared to a love.
Yeah, that's pretty cool. That's pretty good.
That's a really nice comparison. Isn't warranted. Okay. Moving on. Okay, the S stands for separate. So here we go. We're trying to find this. So what you do is you start with the equation they give you. Now, one caution. I've seen people have trouble with this in the past. Just because they give you a differential equation doesn't mean they're going to ask you to find the solution to the differential equation. So don't make assumptions, just read and do what they ask. Here they are asking you to do that. Find the solution to this differential equation. So here we go. Y dx equals. The first step is always the same, and it's really easy. Multiply both sides by dx. Okay, the word separate means I am trying to get all input variables on the right, all output variables on the left, and I don't care where the constants end up. One more time. All inputs on the left, all input variables on the right, all output variables on the left. I don't care where the constants end up. To determine input and output variable, just look at this. This is always going to be change in output divided by change in input. So first step, always the same, just multiply the dx across. Now I want the y minus 1 over here, so I multiply both sides by 1 over y minus 1. I have successfully separated the variables. Being an FRQ question, I've just earned 1 point. Okay? You good? Okay. Next step. A stands for anti-differentiate. So we apply the antiderivative operator to both halves of the equation. Okay, please don't forget, you must use the expanded ln rule here. A is 1, B is -1. So this antiderivative becomes 1 over A, natural log, absolute value, AX plus B, plus a constant. Several people in the room have a name that starts with A, so we will not prejudice those whose names start with C. We'll use A today instead of C. Questions? Please.
Sorry, what rule did you use?
Expanded ln rule. 2 points for Kylie. Questions? So I have 1 over AY plus B. So I have to use the expanded version because I don't have just 1 over Y. So I'm finding the antiderivative. So look at your pink sheet. The third rule down says on the expanded side. You see it? Justin, question. 2 points for Justin and John. Anybody else? Okay. This one's just going to be x cubed over 3. And to be as equitable as possible, we use the letter B this time. Question? Okay, there's no reason to find 2 constants. It's much easier to say, let's just put them together. So this would come over, you get B minus A, right? And then, sorry, we're back to my favorite letter, C. So no bias there. Just kidding, laughing at my own jokes again. Okay. Come on, racer. Stupid machine. Okay. No, you don't ever have to write the A to B. You can just always write C. So no grader expects you to show the A and the B. You just kind of do that in your head and write C. If you don't like C, you can write A. It really doesn't matter. So. On this side. Hold on, take a question for that one. Okay, here's why. You can earn some extra credit too if you can answer this. Think back to the goal of the problem. We start out by saying we're basically in a Danica's chart situation where we know this column is this formula, and we're trying to get this formula, y equals. So there's a reason I don't want to put the C on this side. I prefer to put the C on that side. Raise your hand if you know the reason. There's nothing wrong with putting the C on the right. I just don't want to. So the goal of the problem is to get an equation over here that is going to say y equal. Stop. So why do I prefer to say plus C here versus plus C here? Because it really doesn't matter, but why do I prefer one over the other, Lauren?
Because if the C was on the left side, it would be y plus C.
Yeah, I got to get the C over there anyway, so why not start with it over here, since it doesn't matter. How many knew it? 2 points. Okay. 3 for Lauren. Question? Abby, that answer your question? Yeah. Oh, please.
Is C like constant
C is some unknown value. Some unknown value. So C will be 12, negative 3.
But not like that.
No. 0 maybe. Keep one. Okay. Next letter, look. Right here. Okay, I liked all the words to have the same rhythmic feel to them in hopes of making it easier for you to memorize. So the first word is separate. Second word is, I'm going to laugh at my own joke again, anti-differentiate. Third word is constantate. Yeah, like constantate. You look it up in the dictionary, it says constantate. Verb, to find a constant. Moving on. Okay. At least Marion compared me to somebody who's nice. So, okay. Moving on. You don't know, Sydney was up here talking about Satan and stuff. So I'm like, oh, that was on the video. Sorry. Well, that was a seminary discussion. Oh, sorry, I'm not supposed to talk about religion. Okay, moving on. As I talk in the video, just rolls. Apparently, I'm going to need new enrollment next time. All right. Change careers once, why not do it again? Here we go. To find the constant, look, it's really easy. You know that for this equation, it says right here, look, initial condition, f of 0, oh, it just got cut off, shoot. Yours doesn't help you because you have the same thing. Is it 3?
Yeah.
Does yours show up?
Yeah.
Sweet, mine does not. So f of 0 equals 3. That means when x is 0, y is 3. So in this equation, when x is 0, y is 3. Anybody talk through that? So go back to the big picture. We started with this column identity chart. We're trying to find this. But they told me something about this equation. They told me that when the x coordinate is 0, the y coordinate will be 3. Ah, here's my equation. When the x coordinate is 0, the y coordinate will be 3. So we get ln absolute value. Whenever I replace a variable, I always use parentheses. Question? Awesome. So now you get natural log, absolute value of 2 must equal c. Absolute value of 2 is just 2, so I figured out c now. I hear a voice.
Oh, no.
All right.
Maybe she's not.
Whenever people say that, it always reminds me of the line in the very first Star Wars movie where they attack the Death Star and they get into the command center and they shoot it up and then somebody calls on the radio and says, everything okay? And Han Solo's like, we're fine, everything's fine, just goodbye. Never mind. All right. Moving on. Better story. Sad. Okay. Sorry. So, have I told you, this is totally random, but I just need a better story. If I tell you this story about my son when he was like 3 years old. So this is a good story. Just let it roll. It's good. No, he's like 3 years old, right? Maybe 2.5. And I'm in the kitchen. I'm working on something. He comes into the kitchen, little teeny guy, right? And I watch him. He goes and grabs he goes to the refrigerator. And it was the old style where the refrigerator's on the bottom, freezer's on the top, right? And he kind of looks up at it like a little teeny kid, and he's like, see, he's thinking. He doesn't say anything. I just keep reading at the table. He doesn't even pay attention to me. He goes over and he gets a stool. Little teeny kid pushes it over to the fridge, right? climbs up on the stool and he tries to pull open the freezer. But he can't get it open because like he can sense he'll fall if he pulls too hard, right? So he climbs off the stool. I swear he's only like 2.5. I'm watching, he pushes the stool out of the way. He opens the refrigerator door and he slams it. When the door slams, the force of the door closing pops the freezer door open.
Genius.
Little teeny kid, right? Grabs the stool, climbs up on the stool, grabs the carton of ice cream. Like I'm pretty sure you just let him eat it. Just like you deserve it. He was like 3. Genius. Okay. We found the C. Okay. Look. Don't forget the big picture. The big picture is we're trying to find an equation for y equal. But now we know this. C. Okay. Warning. I think it is best to find the constant first. I think it makes the problem easier. You also collect points more quickly. The goal of the AP test is to collect as many points as you can. If you look at the answers in the back, they often isolate y first, then find c. They kind of do it both ways, but I prefer always find c first. It's just easier. So when you're looking in the back, don't be confused if their c looks different. They're using a different method. You get points either way. Good to hear? So next thing you write down is this. You go back to here and just rewrite this. Natural log, make sure you're using the equal sign correctly. Absolute value of y minus 1 must equal x cubed over 3 plus natural log of 2. Okay, the last step, we have done the constantate step. Now we have the isolate step. Oh, please.
I think it's
Oh, thank you. Typo. That's the bad 3. When I say it's a bad 3, I feel like I'm saying it's a disobedient 3. Back to Satan and such. Okay. Question? Good? Okay. Last step, isolate. We're trying to get y alone. We want the equation to say y equals. You need to remember a rule now. If you don't remember the rule or feel like you've never learned it, we don't care. You don't care. No one cares. Just memorize the formula today. Okay? The formula is e raised to the natural log of anything is just the anything. The related formula is natural log of e to any power is just the power. I need to use that now. So I'm going to take both sides of this equation, and both sides of the equation become an exponent of e. As long as I perform the same math to both sides, the equation is still balanced. Still equal. Question? Okay, this rule now, look, e to the natural log of something is just the something. So now I have the absolute value of y minus 1 is equal to that mess. Question? Okay, I need more space on the board, so give me a second while I copy and erase. One caution. Solving a differential equation is usually worth between 5 and 7 points. The last point can be the worst, like the most difficult part of the problem. Like everything to here went really smooth. Now it's starting to get kind of yucky, messy. If you decide you don't want to spend the time to get that 1 point, don't worry about it. Just move on. Okay? Did I show you how many points you have to earn to get a 4 on the AP test? 60. The AP test is worth 108 points. If you can get about 60, we'll go up and down a little bit each year, but not by much, like 1 or 2 points. If you get 60 out of 108, you get a 4. For every university that I have ever checked, a 4 will give you maximum college credit. They don't give any extra credit for a 5. It's great to get a 5 just as a sense of accomplishment, but you don't have to. So you can lose 48 out of 108 points. You can lose 48 out of 108 points. So if you're working here and you're getting kind of bogged down and confused and it's not going smoothly, you should move on. Go find points elsewhere. There are far more easy points than you can be found doing this. Okay, question? 5 about 72. Only 12 points more. 3 is about 48, 12 points less. So it's not really a very big window. One moment. No, so there's 108 points. 108 points are divided amongst many questions. If you can get 60 of the points, you get a 4. Is that what you meant?
So like how many questions are there usually?
There are always exactly 30 multiple choice questions where you cannot use a calculator. There are always 15 multiple choice questions where you get to use the calculator. There are always 6 FRQ questions, 2 of them with a calculator, 4 without. The FRQ questions are typically divided into parts A, B, C, and D, although sometimes A, B, C, sometimes A and B. So once you kind of break them out, it's like, oh, I don't know, 6 times. It's kind of like having, and some, even part A and B sometimes has multiple questions. So I'd say the FRQ is more like having, I don't know, 30, it's pretty similar, you know, it's like 35 little things you got to do somewhere versus 45 on the multiple choice.
And the FRQ is like just doing this. Basically.
These are examples of FRQs. These are exact copies. This is from the 2004 test. Okay, look up. Okay, same thing again. If you don't remember how to solve an absolute value, don't worry about it. I'm going to show you right now. So if you don't have any recollection of ever doing it, it doesn't matter. It's not hard. You just have to do what I'm going to do. The concept's really simple. Look over here. If you have the absolute value of y minus, we'll just, let's see, let's make it easier, of y is equal to 8. There are 2 possible solutions for y. There's 2 values y can have. What are the 2 values y can have? Don't overthink it. Hands, come on. What are the 2 values, Helen?
8 and -8.
Hands up if you agree. 2 points, 3 for Howard. Okay, look. Look at this. Come on, look over here. So the method for solving an absolute value, like the way you get rid of the absolute value bars, is you simply recognize that there could be 2 answers. It's very much like a square root. There could be 2 answers. Either y minus 1 is going to equal exactly what you see here, just like we did here, y equals 8. Or y is going to equal, y minus 1 is going to equal this with a negative sign. Okay, it's one of the 2, just like over here. Just like you did here, you just do the same thing here. You need me to talk through that again. Oh, it is plus or minus. It's plus or minus the whole thing. The whole thing, hence the parentheses.
If we were to distribute all the negative out in that bottom one, would it be
No, because this is really just e to stuff. So the negative doesn't apply to this, it only applies to this. So you just have that. Yeah, this is just -1 times, like this e to all this stuff. So it's just really this e to all that stuff. The negative does not get applied anywhere else. Is that what you meant? Yeah, 2 point. Please say. Yeah. Okay, don't talk. You okay with this?
Yeah.
Good. So I'm doing the same thing. I want to get rid of the bars. So that means what's in the bars, y minus 1, might just be what you see. Just like here, what was in the bars, y is exactly that. Or it's possible that what's in the bars is the negative of that.
Yeah.
So I made this negative. But this is e raised to a bunch of things. So the negative doesn't show up in the exponent. The negative is just with the e. Any question? It's just -1 times. Like it's not negative e. It's -1 multiplied by e raised. There we go. Okay, erase this.
But it still can be the positive version.
It's one of these two.
Okay.
Yeah, the solution is one of those two. Here's how you figure. It's not both.
Yeah.
The answer is one of them. You figure it out by doing this.
Sorry, do we want to move the next -1 by -1?
We will. We will. 2 for Elena. Okay, look. Okay, again, what we're doing now is worth 1 point. Like, to here, like, look in the back. Problem number 10. Look in the back. The answers. Problem number 10 is worth 6 points. Solving for y is worth 1 of the 6. So if you feel like it's just taking too long, then you should move on. Because you've already earned 5 of the 6. But anyway, the last step is what Elaine is talking about. Only one of these two is correct. Here's how you find out. You use this information again. This says whenever the x coordinate is 0, the y coordinate is supposed to be 3. So let's check it. Go over here. Try, this one's the one that doesn't work. Put a 0 here for x. What's 0 cubed? 6. Divide by 3? 0. Plus ln of 2? ln of 2. Come on, stay with me. What's e raised to the ln of 2? 2. Times -1? -2. If I bring the 1 over, I'm going to have -2 plus 1, which is -1. That didn't work. Wait, if you need me to do it again. 3. Don't worry. Right, because remember where we started. We had Danica's chart. We know this equation is x squared multiplied by y minus 1. We want to find this equation, but this equation is such that if you plug in a 0 for x, you're supposed to get a 3 for y. So I'm trying it. I've got this equation. I want to plug in 0 for x, see if I get 3 for y. When I plugged in 0 here, I got 1, -1. It's to check which answer is right. Because I currently have 2 possible answers. I need to figure out which one works. So here, look, same thing again. 0 cubed is, come on, 0. Divide by 3, 0. Plus ln of 2. E to the ln of 2 is 2. Plus over the 1, it works. This is what belongs right here. Okay? That equation goes right here. Please, Mary.
So in the answer, it has 1 plus 2 e to the 1/3 x cubed. Can you do the e to the l 2?
Let me see. Hold on, Mary. Oh, I know what they do. Hold on. Take a question from Aaron. Hey, watch. Look up. Come on, look at me. Look up, look up, look up, look up. Everybody looking. Okay. This is perfectly correct. Full credit. What they did is the following. I have seen, okay, what I'm about to show you is not something that shows up a lot on the AP test, but I have seen it show up on a multiple choice question where you get this answer and it's none of theirs, and you would have to do what I'm about to show you to get the multiple choice answer. They use a property of exponents that you've used before. The property is e to the a plus b is the same thing as e to the a multiplied by e to the b. Okay? Property of exponents. You use it all the time with a really simple example. Like, look at this one. E to the 2 plus 3, that's the same thing as e to the 5th. And that's the same thing as x squared times x cubed. Like, this should look really familiar to you. X squared times x cubed is x to the 5th. So this is not a fancy rule, they're just using it in a different way. So they're going to take right here, e to the a plus b, and they're going to rewrite it, so like this. So you get y equals 1 plus e to the x cubed over 3 is the same thing as 1/3 x cubed. So they wrote it like that. Multiplied by, that's a terrible fruit, e to the ln of 2. Does anyone need help getting from this red to this blue? What is e raised to the ln of 2 the same as? 2. Okay? That's all they did. Is that not the answer in the back? You do not have to take that step. But that's how they got it. So. Question. Awesome. Next thing.